So, good afternoon to all. I welcome you to the afternoon session of day one of AICT Sports Atal program for waste management technology. Our next speaker is Mr. Gauri Shankar Prasad, who is going to present on the topic waste management and recycling in steel works, challenges and opportunities. Before that, I would like to give a brief introduction about our speaker. Mr. Gauri Shankar Prasad was heading Rourkela Steel Plant, one of the integrated steel plants of Maharatna Company sales since 1st October 2011 till 30th September 2015. Before taking over the reins of Rourkela Steel Plant as Chief Executive Officer, Mr. Prasad was Executive Director of CET SAIL at Ranchi, a fellow of Institute of Engineers as well as a life member of Indian Institute of Building, Indian Institute of Metals and Management Association, Rourkela. Mr. Prasad has visited several countries including USSR, UK, France, and Japan, and has been trained in different aspects of steel making and maintenance. Under his leadership, the steel plant has also bagged the prestigious CII Sustainability Award. Apart from array of awards in the field of business excellence, environment management, safety, quality, human resource, and corporate social responsibility. Post-retirement from the RSP, he was also associated in acquisition process of Bhushan Steel Limited under NCLT, which was eventually taken over by Tata Steel. Today, he will present his industrial expertise and enrich us. Over to you, sir.
Thank you very much. Good afternoon, everybody. Sorry for the delay because technology sometimes makes life easy, then sometimes it makes life difficult also. So once again, good afternoon, and at the outset, I must thank the management of CV Raman Institute and organizers of this web seminar. Especially, I must thank Dr. Sunil Sarangi, who has invited me for this particular talk, and Dr. Sunita Rotrai, who has really made this possible, giving me an opportunity to be among young mind. I think Dr. Saab, Sarangi Saab, I'm not so older, but I think the audience must be young, isn't it? So after long time, I am physically interacting with all of you, and it would have been different had I been present amongst you. But the pandemic has led us to here through web. Nonetheless, let us make use of whatever time is available to us. Now, coming to the topic on waste management, I, being a person from steel fraternity, will be dealing with the waste generated, environmental concerns, research areas, and future prospects. With this backdrop, let me start my presentation. So, the steel is a versatile commodity that plays a major part in everybody's life. As sale as a slogan, there is a little bit of sale in everybody's life. You must admit that whatever things you are doing, whether you are eating, whether you are cycling, whether you are making some strides, or anything that comes to your household, many articles are mainly made of steel. And why it is so? Because it is a high strength material and resilient material. Plus, it has got an advantage of getting recycled every time. Nothing is wasted in the steel industry. So, since ages, time immemorial, you can say that after the Stone Age, the age of iron age came, and from then onwards, this iron and steel is an industry which has never left the humankind. Although there are many other material has come alternatively, but steel is still to be replaced for many of the applications. With this, you can always say that it is a very high strength and resilient material. As such, most of the metals are recycled again and going into the melting. You will also find this as the largest category of material in municipal waste, whatever we use. Like if you drink a cold drink, that can is made of a steel, and anything you touch, definitely you will find some steel in the of it. So this is the largest category of material being used all over the world. Now, let me go to the before knowing the solid waste generated in the steel plant, we should know what is the process. And as you are seeing, it starts from mining and then raw material handling plant. From mines, the steel plant receives material like iron ore, coal, then limestone, to name a few, and they are coming to either coke oven coal receiving yard or the ore bedding and bending plant. Now the cocoa ones I will be dealing one by one, definitely. Then sinter plants, blast furnaces, steel mill shop, continuous casting shop, rolling mills where the things are getting different shapes into long products and flat products. So all these processes definitely produces some kind of final finished products and some side products which are called solid waste in the earlier days, but right now we call it as byproducts as we find some use of these solid waste or the chemical waste or gaseous waste or sludge, etc. We find some use, and these are getting recycled, regenerated. Hence, these are now called byproducts, and which helps in getting revenue for the plant. So mines, as you know, that iron ore and basically iron ore, limestone, dolomite, etc. are mined and transported to the integrated steel plant. Mines, I will not be dealing in detail, but that also creates lot of iron ore fines, which earlier were not getting used, but then it was around 60 to 70% getting wasted as fines. So all the researchers put together and they found out to make it sinters which are chargeable in the blast furnace. That you must be knowing, all of you are engineers. So the sinter plant basically was designed and made to work for making these fines getting used, because in sinter plant we try to make cakes. We mix it with some conglomerate, and this total mix is passed through furnace, and this gets fused together, and it is basically coke bridge and iron ore and binding material, lime as binding material, and these are, when heated up, this gets fused and form into cakes, which are then broken into chargeable size, and as sinters they are charged into the blast furnace. So this is the first use of that iron ore fines which were lying in the mines earlier, but now nobody thinks about it because iron ore fines are also consumed and not available in the mines these days. In the mines, there are slimes also produced, which are getting collected. And as you know, now the pellet plants are getting making use of this ultra fine dust, which are fused with the binding material and made into pellets. So, steel fraternity or the researchers have tried to use most of the natural resources from mines. Then raw material handling plant, as I told, that whatever material comes other than coal is getting into the raw material handling plant, and there it is sorted out, and it is ore bedding and blending plant, because before charging the material into the sinter plants. Am I getting boring? Please, Madam Sunita, am I getting boring?
No, sir, not at all, sir.
नहीं तो आप बीच में आप अगर मुझे रोक भी सकते हैं, ऐसा कुछ बात नहीं है, because if it is getting into here. So that is a work where it is mixed in a proportion and it is made into over bedding means it is laid as a bed, and blending is also done of different material for charging into the sinter plant base mix. So that's why it is called OBBP, and raw material handling plant because it receives iron ore, dolomite, limestone, and all these materials which are supposed to be fed into blast furnace for making iron, hot metal. And the other stream is the cocoa ones, where the coal handling plant handles the coal for coking coal and other type of coals which are mixed in different proportion, basically prime coking coal, secondary coking coal, and normal coal dust is mixed in certain proportion, and they are charged into the cocoa ones, where you know that it is heated in absence of air to form coke. Now this coke is fed into the blast furnaces. So once the blast furnace, as you know that it is mixed with sinter, iron ore, and coke is fed into this, and hot air is blown into the blast furnace through 2 years, and making the hot metal some slowly matlab melting. The melting takes place and it is collected in the belly, which is tapped from the blow means it is tapped into the furnaces, means through the holes, tap holes, through the tap holes, the blast furnace. So tap holes, which is called for tapping the hot metal. Along with the hot metal comes the slag also. The slag being the lighter material, and basically it is made of calcium silicate, and this blast furnace slag is passed through a screen of water, means the water is sprayed into this, making it into small granules, and that is called blast furnace slag. That blast furnace slag is collected and taken to slag yards, blast furnace slag yard. And hot metal is taken into hot metal ladles, and they are taken to steel melt shop. Now steel melt shop nowadays, open hearth furnaces nobody is taking up. So it is basically LD converters or basic oxygen furnace, because the hot metal is blown, oxygen is blown into the hot metal collected in the converters, and where you know that carbon is reduced to say minimal level, and then carbon added, and steel, the carbon percentage available varies from zero point 0.4 to 1.6, 1.7, sometimes higher also, depending on the end product and the strength of the product. Because rails, you must know that it is of a high carbon, but carbon makes it more brittle, so some alloying elements are also added to make it more ductile. Now this steel which is coming out here also, the top portion, the slag is floating. So first slag is tapped out, and this is called basic or oxygen furnace slag or LD slag. And from lower area of the converter, this hot steel is tapped, and into steel ladles, which goes to again continuous casting shop, where it is cast into slabs or blooms or billets for further getting it into rolling mills. Now rolling mills can be of two types: for long products, that is for rails, billets, blooms; merchant product, wire rods; and flat products like hot rolled coils, CR coil, plates, sheets, GI products. So GI products means it is hot dipped in galvanizing is done for giving a quote for durability. And similarly, hot tinning lines are also there, where hot dip tinning is done. So these are this today my topic is not steel making. Today my topic is waste management in the steel plant. So to give you idea, I have given the little bit production process, so that all these processes, there are some waste being generated which have to be managed. This is a big challenge, which you will see in the next slides. We have also very much the environmental concerns. So all these wastes are to be processed in such a way that it gives a minimum impact on the environment. The steel industry is a very polluting industry, and that's why in each stage there are a lot of pollution control equipments to control the emissions and contaminations. So with this, I will also go to the next slide. Now these are the supporting. In the earlier slides, I have shown you the main production unit. Now these are some supporting, some of the supporting departments. Now the first is safety department, S. Then plant medical, it is health, that is H. Then environment management department, that is E. So you must be seeing she. So this becomes the most important aspect today in the steel plant: safety, health, and environment. Because as you know, steel industry is very much polluting industry. So we have, and a lot of dangers are there in the total process. So lot we have given most priority to safety of the people and health of the people and environment, which which is available in the plant or in the townships. uh, we are giving full attention to this, and today all the steel plants are really gearing up for making this uh, atmosphere very clean, and environment friendly atmosphere in the plant. And for that, you know that all the ISO systems are being followed. For safety, it is ISO 18001. Environment management is ISO 14001 EMS. And health, also we are following the ISO systems. Then fire services is another important area, department, which, because as you know, we are dealing with fire, heating, and hot metal processes. So Asha, please. So fire services, and then the maintenance department, mechanical and electrical, obviously all the equipments are to be maintained. Then power generation is another area which is very important and very polluting one. Power generation is required to captive power plant, although we take power from outside grid, but there are certain equipments which are supposed to run continuously without fail. So for those, we have to have alternate source of power, and captive power plant exactly does the same, because there are many areas which, if it fails, it will create havoc in the plant through leakage of the gases. You must be aware that many times one or two cases have happened when the blast furnace gas has leaked into the atmosphere, causing deaths also. Then another area is the oxygen plant. It is normally oxygen plant is there for getting oxygen for blowing into the converters. Then energy management is another area where we are putting our all attention, because energy, when the energy is consumed, when the less energy is consumed, means less impact on the environment. And as you know that our aim is to reduce the overall energy management, and today steel plants are having around 6.4, 6.5 gigacalories per ton of crude steel. And still further, the endeavor is to go up to 6 or even below 6. Uh, by this energy management, this is a measure of all the plant for efficient working of the plant, because it considers all the energy which we spend in form of coal, bullion, yeah, anything you talk, it is done. So basically, once a efficient energy management is there in the plant, it means it is giving minimum impact to the environment, which is our goal today, because the carbon emissions have to be controlled for obvious reasons like global warming and other concerns which you must be aware of. So all plants, we really strive very hard to reduce the carbon emission. And steel plant is a organization which consumes coal very heavily, because coal is required as coke for melting the iron ore and getting iron. Another area of concern in the plant is another resource which is extensively used is water. And to give an idea, even the makeup water, which constitutes around 3 to 4%, is like 5,000 meter cube per hour. So water is another resource which have to be handled very carefully, and most of the water is recycled. Now, the steel industry, as I told, all the departments, all these processes generates a lot of waste or byproducts, as we call it. It is like if you consider solid waste, it is slag, dust. GCP sludge is the gas cleaning plant of blast furnace. It contains a lot of dust. So GCP, once it is washed, it forms a GCP sludge. And coke bridge. Now coke of size, say 40, 35 plus 35 to 80 mm is charged into the blast furnace directly. The nut coke is around 20 to 35, 38 size, that is also charged into the blast furnace. But some minus 15 or minus 20 coke size. Minus means it is less than 20 mm size. Okay, so that is called coke bridge, and it is depending on the strength of the coke which we generate, which is again dependent on the type of coal we are using and type of process we are using. So whatever you can do, but certain coke bridge is also generated which have to be used. It is reused into the making base mix and again charged into the furnace. So used refractories. Now all these processes or blast furnace बोलिए या steel melting shop बोलिए or these and reheating furnaces of the mills, these have extensive use of refractory bricks. So these bricks are supposed to be uh, replaced time to time, and uh, so there are a lot of used refractories getting generated. Then metal scrap, because the iron skull is there. Once the skull from the ladles, that skulls are getting accumulated in the bottom of the ladle, which have to be broken, and that also contains iron. Then in steel ladles also the skull is formed and a lot of steel is there. So these have to be broken into small pieces of chargeable size and then reused. Then mill scales are there. So in the process of rolling, we do a lot of descaling, or the scale which is formed on the surface is getting it is there and it is detrimental for rolling. So we primary in the primary descalers and the secondary descalers, we take out these scales which gets accumulated into the settling tank along with the processed water. So this mill scale is also generated in the mills, and lot of muck and debris are also uh, generated during all these processes. Then there are liquid waste, as I told you that all the cooling, uh, all the process require lot of cooling of the equipment and lot of cooling of the process means process material. So these creates lot of industrial effluents. Then oil and grease is extensively used in the equipment, so that also creates a lot of liquid waste in form of uh, processed water getting mixed with oil and grease. Then acid sludge in the pickling lines when we do the tinning or galvanizing. The surface of the sheet has to be pickled for cleaning. So that is called pickling line. So that is done through acids, either hydrochloric or sulfuric acid. So it also forms a lot of acid sludge. And then gaseous waste, as you know, that whenever we burn, there are a lot of flue gases getting generated. Fumes are getting generated by means of cooling. Then acid fumes when we are doing pickling. The whole area is quite filled with acid fumes. And then we have to extract it by through say exhausters. Then we also have some radioactive waste. It is not a gaseous waste, radioactive waste, because the measuring instrument and other equipments, there are a lot of radioisotopes are used in the system, which after the life cycle has to be disposed of. So these are few categories of waste or byproducts we are making, and one by one, I'll be telling that what we do out of it. Now, as you know that we are earlier also I told that we are very much concerned with the environment, and all the industries today are um, trying or craving for conducting their operations in such a way in order to have minimal effect on the environment, because as you know that mother earth is natural resources are limited, so we have to optimize the uses, and that's why we all the steel plants are following now the 4R principle, that reduce consumption. So that can be done through improving process efficiency by adaptation of latest technologies like coke dry quenching in coke ovens, where the use of quenching water is not there, rather it is cooled by nitrogen initially and then the coke oven gas itself. uh, so that no water is used for quenching. So CDQ is one latest technology which is being used in coke ovens. Then coal dust injection in blast furnace. Now coal dust injection, the replacement ratio is 0.9. Means if we burn 1 kg of coal, 0.9 kg will be effective in heating the air. But we cannot totally depend on coal dust injection, because the total stack in the blast furnace, it has to have some holding strength. So that for that coke is required, but the coke consumption is reduced considerably with CDI, that is coal dust injection, and endeavor is to maximize this coal dust injection. Now the plants are having coal dust injection level up to 160 kg or 170 kg, even going up to 200 kg in some foreign plants. So this is done through adaptation of technologies like high top pressure in blast furnace. Then we have improved blowing process in BOF and better shape control by HAGC in mills. to reduce the scrap. What happens that blowing process we are continuously endeavoring to reduce the consumption of lime, consumption of hot metal, coal to hot metal ratio. We are trying to reduce, and all these process parameters are getting improved. And in the mills, what happens that whatever is out of shape has to be cut. That is front end, back end, and sides are to be cut. In flat products, the sides are also cut, and in the long product, the front end and back end are to be cut because they are not in shape. So to reduce this rejection, we are using technology like hydraulic automatic gauge control, so that the scrap generation is reduced. Then the second principle is recovery. As I told you that coke bridge, or we will see that how the iron particles are removed and they are again recovered to be charged into the blast furnace or steel melting shop for again making the product. Then reusing, like we are having lot of oil, that lubrication oil and hydraulic oil. So we have got especially oil reclamation unit for which dirty oil is cleaned in the system, and again it is reused wherever possible. At a few places fresh oil is only required, but a few places we can always use the used oil. So reusing material we are maximizing. Then process water. As I told you, the makeup water is some 5,000 to 5,000 to 8,000 per meter cube per hour. That is depending on the process and the product of the plant. Now, but the total water requirement in the process is very high. So all this water is cleaned in the secondary settling tank, or in the primary settling tank, secondary settling tank. Then oil skimmers are there to take out the oil. Oil catch pits are also there to take out the oil, whatever is getting mixed into the oil, into the water. And this clean water is again sent back or recycled into the process. So that process water is there. Then any spillages we always collect. Even the rainwater, when it heavily raining, some oil gets mixed into the rain, and from the yards it gets into the air. So we are making check dams for this oil, and oil is getting reclaimed out of it. So wherever possible, we are trying to use, and with the advent of this ISO 14001 and adoption of ISO 14001, lot of your lot of processes have been adopted to really reclaim and recover the spillages and reuse it. Recycle the waste and spillage, it is the same. So now, what are the type of solid waste? So solid waste from process units. Now coke oven and byproduct, as you are saying, whatever is there, it is coke bridge, tar sludge, and acid sludge. Now how tar sludge and acid sludge? As you know that coke oven, we heat the coal in the absence of air. So it contains hydrocarbons which gets converted into gas, and this gas after cleaning is led into the coal chemical plant, CCD, and there we are separating by fractionating method. All of you must be knowing the fractionating tower method, and we separate out different byproducts like tar, benzol, then ammonia, then acid. All these are separated, and ammonia in few places is used for making ammonium sulfate, which is used as manure, as you know, and it is available with the brand name of शायद सोना बोलते हैं इसको, सोना खाद. yeah, Raja Khad, yeah, I don't remember exactly the name, but Sona Khad, ammonium sulfate. So that is being produced, and sludge, acids, all this tar is sold into the market, and this the bottom portion, it is tar sludge is there, so it is again sent to mixed with coke bridge. It is formed into the briquettes, and again trying to use it into for burning for as a fuel. Acid sludge also is like, because acid is also getting produced in the process, and acid is being used for ammonia. This acid sludge is also generated. So after the pollution control equipment, we get coke fines or sludge and BOD plant sludge. Now BOD I will deal it later on. Then from sinter plant, undersized sinter is also produced, and there are suction available for letting the air to pass through the sinter bed. So it also produces sludge and dust in form of chimney. When the gases are emitted out of chimney, it is washed, and the dust and sludge is getting collected in the electrostatic precipitators. So that is also a type of this waste product is there from this process center. Then blast furnace slag, I have told that the top floating surface of the hot metal is containing, it is lighter and calcium silicate, and it is passed through the water spray, and it is getting into getting collected as fines, granules, and that is called blast furnace slag. Then BF sludge, again from BF chimney, stove chimney, and this gas emitted when the blast furnace gas is being cleaned through scrubbers and your electrostatic precipitator, then the BF sludge is also generated. SMS slag, steel melting shop, the top portion, as I told, SMS is the top portion of floating portion is the slag part, that is the impurities which are taken up, and it is loaded outside, and it is formed into solids. Then broken refractories, because why we have written here refractories, because steel melting shop, that lining is to be replaced. In blast furnace it is not like that. The repair takes after say 2 years, 5 years or 10 years. But in case of steel melting shop, the LD converter lining is to be replaced after say 300 hits or 400 hits or 600 hits. Now it is endeavor to maximize the lining life, and good results have been obtained into it. But nonetheless, after say 2-3 months, or 1 month, the LD converter have to be taken down for replacing the refractories. So lot of used refractory are getting generated here. So that also, and again SMS sludge, wherever it is there, it is through the chimney where the finer dust is washed, and through scrubbers and electrostatic precipitator and getting collected. So SMS dust and sludge. And in the rolling mills also, there are reheating furnaces. So used refractory, the reheating furnaces may be getting repaired in say 6 to 8 months, but also sometimes breakdown happens. A lot of used refractory, broken refractories are getting generated. And end cuttings, I told, when the shape, in the case of long product, it is the front end and back end, but in the case of flat products like HR coil and plates, it will be front end, back end, and side trimmings also. Now, from the pollution control equipment, the mill scale, I told, it is getting mixed with process water. So it is collected in the primary settling tank and secondary settling tank. And in the process, the lot of oil and grease is used in the mills, which gets mixed with the process water. So that also it is getting separated. And oil is skimmed out through skimmers, and then oil sludge is also getting generated. Then in the raw material handling plant, dust and sludge, because as you know, when we handle material through material handling equipments, it is definitely bound to give rise to breakage of the uh, raw material and getting into dust, and then again sludge sometime, because it is in the open. So when the rainfall takes place, a lot of things are getting washed off into the drains and sludge is formed. So with this backdrop, now again I told we have to make use of 4 R's. So how do we do it? The analysis of solid waste are being done. What is the composition? What is the size? So it is analysis of solid waste are done, and alternate uses are found, which we'll see later on. And I can tell you that nothing is wasted in the steel industry. It all gets recycled. How does it affect? Why do we do it? Because why should we bother for solid waste? We could have left it like in the earlier days we were living. Why should we bother? Now, as you know that our Mother Earth is having limited natural raw materials. So all this analysis and use of solid waste are resulting in reducing the requirement for natural raw materials. Thus, we are trying to enhance, or we are trying to make more these raw materials to last for more number of years. At the same time, once we are trying to reclaim it and reuse it, it reduces impact on environment and prevents land pollution. We, by means of selling certain products like scrap and metal, we are also trying to support, and that tar, we are also trying to support the ancillary industries for manufacturing of pellets, micro pellets, re-rolling mills, and scalps, to name a few. There are many other uses of the ancillary equipment, ancillary industries. Now coming here, this gives a typical generation and utilization of solid waste in a 4MT plant. See, blast furnace slag, this is to give you an idea only. It is, figures are indicative. For a 4 million ton steel plant, the blast furnace slag generated in a year will be to the tune of 13 to 15 lakh tons. That is 1.3 to 1.5 million ton. And it is sold to cement industry. 100% of the blast furnace slag, which I told, is sold to cement industry, as it is a very good raw material for cement making. So nothing is getting wasted here. And BOF slag, which is a problem area, as you will see that we are using only 24.6%. That I'll be dealing into detail, because this is a problem area. And generation is around 6 lakh tons. We recycle around 1.4 lakh tons. We have not found any much alternate uses for selling it outside, but we have been doing a lot of research work, which I will discuss in detail later on. And total utilization is around, because we recycle, so around 1.42 lakh, which constitutes only 25% approximately utilization of BOF slag, that is the SMS slag or the LD slag. Lime fines are burnt lime is required in the process of blowing and in the charging into the blast furnace. So lime fines are generated, and this 100% around 1 lakh ton. So this is 100% utilized in sinter making. As I told, that sinter, we mix coke bridge, iron dust, iron ore fines, and lime as a binder, and we heat it. We mix it with water, and the slurry, the paste, or the we try to pass through a furnace through by the pellets. It is charged into the pellets, and it is passed to a furnace, and we suck, we force air to hot air to pass through the sinter bed, making into sinter. You can say that some reduction is taking place in the process of sintering, that eases out the reduction process in the blast furnace, because the blast furnace is a reduction process for making the hot metal. Then BF sludge, the sludge from connected from the BF chimneys, from the electrostatic precipitator, and BF flue dust, BF sludge, that is going for sinter make base mix preparation for sinter making again, because sinter is a basic product which is charged into the blast furnace. So we try to use all the iron particles or anything such, all resources which are getting generated to the solid waste into the sinter making. Then blast furnace sludge, as we see that it is going very fine, so it is BF flue dust, it is very fine. We also try to make pellets out of it and briquettes out of it, again for melting purposes. Then SMS sludge, now here also you can see that the utilization is 68%, and it is also used in base mix preparation of sinter making, and it is also sold outside for making pellets and briquettes, which can be again used in small furnaces, small melting furnaces. Then oxyacetylene gas is extensively used for cutting. So we have acetylene plant. So acetylene sludge, that is a lime. It is produced through a process which uses acetylene gas is generated, but the acetylene sludge, which is type of lime which is used for whitewashing. Then fire clay and refractory bricks, I told that a lot of refractory bricks are getting generated. So high value refractory bricks are sold outside, and fire clay and refractory bricks are sold 100%. So that can be utilized for pavement making of the road, and lot many uses. As a landfill also you can use wherever walkway is required to be made. These fire clay and refractory bricks are very much useful. Then mill scale, it is getting generated up to the tune of 50,000. It is all the quantities are in tons. So 50,000 tons is generated. It's typical for a 4 million ton steel plant. The quantities may vary here and there for for various plants, depending on the again the process and the technology adopted. So this mill scale totally goes into base mix preparation, because it is iron oxide. So it is pure iron oxide, and which is available, and this is used in sinter making for again charging it into blast furnace. Thus we can see that around 80% of utilization is done, and the 80% of solid waste are getting utilized or recycled back in steel making, and like blast furnace slag is sold for cement making. Then the BF slag, which I will be dealing in later slides, and pellet making, etc. So as I told, BF slag, you must have seen that we are using only 25%. So it's a problem area for a steel plant, as it is not 100% utilized as in the case of blast furnace. The BOF slag, after getting unloaded, it is into a solid form. Just a minute, please. So BF slag is a problem area for steel plant as it is not utilized 100%. The BF slag is crushed into two stages, and by magnetic separators we take out the iron particles. Now these iron particles are either charged into the blast furnaces or also sometimes in the LD converters as a coolant, and also going to the sinter making. Now, after the total 2 times or 3 times separation of the iron particles by crushing, the remaining portion remains as work through slag. This is actually covering lot of area in the plant. Now, this BF slag is containing free lime, and because of that, it absorbs moisture. So, because if it is not seasoned, the fresh slag which is getting generated, it has got an inherent property to absorb moisture and get swelling up. So that's why it is not used as a material, because it has got a potential to be used in road making as a replacement for the stone chips. But the property of absorbing not getting used, and because the it will get swelled and the road will get damaged. So before using into um, these areas, the seasoning is required, withering or seasoning is required either through natural resources, and nowadays we are trying to mature it faster by steam maturing. So to solve this problem of BF slag, R&D has taken certain initiatives in collaboration with reputed institutes. Now, use of BOF slag as a rail ballast. We have tried for using as rail ballast. The railway requires a lot of stone chips as ballast to be supported, so to be used. BF slag there, but the strength is not there. And swelling of the chip. So we have tried to fermentation maturing of BF slag for faster maturing and effective utilization. One area for BF slag is blast furnace slag, a dry granulation of blast furnace slag for making the blast furnace slag. Now, why dry granulation? Because uh, this uses lot of water as a water resource, and water is very precious. So we are trying to save on the water uses, and this one being one major area. We are trying to use dry granulation, that is by passing it through air curtain. But this is still in not a very popular method. It is a experimentation stage, and it has not been 100% into technology now. But experimentation are going on for this dry granulation. Similarly, blast furnace slag in road making as a substitute of natural aggregate, as I have told. Now, BF slag we have also tried to use as soil ameliorant. We use it because a lot of lime is there. So neutralize the bad effect of the acidity. We are using this mixing in with soil. So this is also experimentation has done. in the concrete making, this BF slag in place of natural aggregates in accordance with the IS 383 2016, we are trying to make all these uses, but nothing has been very successful till date. Now we have also, as soil ameliorant, actually RSP collaborated with your own institute, Odisha University of Agriculture and Technology, Bhubaneswar. So acidic oil was neutralized by mixing with this slag rich in calcium for improving soil fertility in Sundargarh, 3 districts, Sundargarh, Khurda and Keonjhar. And results were encouraging, but it is still in experimental stage and a lot of potential in this area, because you can understand that if the soil fertility can be really enhanced, it will be of much use, and the results are like this. So you can see the percentage increase in production, especially groundnut it is 50%, tomato it is 45%, potato 42%, 40%, and gourd it is 40%. You can see the lot of improvement is there. And in the marigold, that is flower production also, that is not appearing here. It is more than 30% or so. So this actually it was done with Dr. Just 1 minute, please. This project was carried out by Professor Santanu Mahanti and his team, and it is in yeah, sorry, and lot of scope in this area if it is really successful, but still it is pursued. Now, generated to give you an idea, at Coke Bridge around 3,72,000. Similarly, Sintra Fines it is around 26 lakh tons. Then iron scrap it is 33,567 tons, and steel scrap is around 395, around say 3 point around 4 lakhs. So all these are 100% utilized, and area of utilization is in that is Coke Bridge is going to raw material handling plant for base mix preparation for sinter plant. Then sinter fines which are getting generated are again fed into the sinter plant making for sinter. Then iron scrap and steel scrap both are going into the LD converters, that is basic oxygen furnaces, and because 15 to 20% charge in the LD converter is metal scrap, and this metal and iron scrap, and this is also used as a coolant, because once you know that by charging the hot metal into the converter, the bottom portion of the converter gets impact energy of the hot metal. So to reduce that impact, we charge first the iron scrap and steel scrap in the bottom, so that the impact is less. If I am not clear or any doubt, please interrupt me, madam. Hello?
Yes, sir.
Hello?
Yes, yes, sir.
All of you got bored, huh?
No, sir. Actually, sir, first you complete, at the end they will be given a chance to ask questions, sir.
Definitely, because if it would be one to one, interaction, it would be easier talking in between. But
Yes, sir.
here it is not.
That's the problem in
Uh,
online, sir.
but 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 that is a better way of explaining the thing.
Yes,
But
sir.
anyway,
Definitely.
so these are the end uses of solid waste. Then I told that power generation is another area power that we are having captive power plants for making available power, uninterrupted power to the steel, certain units of steel plant, which are required to run continuously. And if they stop, they will play havoc in form of leakage of gases and other items, or it may damage the equipment. Suppose the water supply in blast furnace is stopped, then the whole equipment will get damaged. And certain times when it happens, it damages certain things. So we are having power plant, but generation of power plant we use mostly now. We are trying to use blast furnace gas and carbon dioxide gas and coke oven gas and blast furnace gas and mixed gases. So the LD gas is used in mixed gas. So all these gases are trying. We are trying to use power generation through gases, but 100% it is in the new units we are trying to do it. But in the older units, still the power coal is used. So power burning power uh, generates effectively and very cautiously so that spillages are not there. But there are a lot of end users and future prospects for the users of fly ash. Um, how do we do it? Actually, all the fly ash getting generated is made into slurry nowadays, and it is pumped through ash ponds, especially made for the purpose with strong dikes so that nothing leaks up. So that is one thing. Otherwise, it is through precipitators and rivers. All these are getting collected into the trucks, covered, and it is made by sprinkling water. Then it is covered by sheets into the transporting designated for. So it's used for abandoned mines, dump this fly ash, say 5 or 6%, maybe 10%, has become mandatory by government of India to use fly of India. But there also we have to bear the local transportation cost and for use in making pavements. Highway Authority of India must have seen that around 2 meters, and then filling material is construction. So there we are trying to use and the transportation cost, but steel plant, the power plants are smaller, but they are power generation units which are like NTPC and other units of power generation, that is thermal power generation. A lot of fly ash is getting generated, and it is a problem for everybody. Fly ash has also been experimented for cement making, and few plants have come up to use this as a raw material. Hollow lean concrete bricks that and float as a landfill in road construction by management. Now there are certain hazardous waste which are getting generated. We will see what type of. So they are being managed by uh, Management and Transboundary Movement for Hazardous Waste Rules 2016. So we try to recycle all the types of hazardous waste, but wherever it is not possible to be recycled, these hazardous waste are to be dumped in a specially made secure landfill with an impervious layer, so that there is no leaching into the soil and subsequent soil contamination. As I told in the earlier slide that there are radioisotopes also being used in certain measuring equipment which have to be uh, actually stored and handled very cautiously, and they are authorized agency like BARC to dispose of these radioisotopes. So there must be, whenever we buy, there must be um, the giving back contract or something like that, agreement that BRC has to take it back. And without their permission, we cannot use any radioisotopes. Now, these are few types of hazardous waste management in steel plant. Now we see that oil sludge, it has got a potential to contaminate the in a secured landfill, and figures are basically typical for a 4 million ton steel plant. So if the plant is smaller, the quantity generated will be less, and the process will also depend on the process we follow. And this control equipment, pollution control equipment which we are having. So used oil is always recycled. As I told, that hydraulic oil or the lubrication oil, it is reclaimed in oil reclamation units, recycled and reused. And chemical sludge from wastewater treatment plant. Uh, we use lot of chemicals in water treatment, so these are also recycled and reused 100%. And the generation is 120 ton per year. And from coal chemical department, I told that tar is getting separated, so most of the tar is utilized, and decanter tar sludge. So when we the tar decanters are there where the tar is getting collected. So this tar sludge is recycled back to coal handling plant for making mixing with coal for charging into the cocoa ovens. It also improves mixing of this tar into the cold chargeable coal, which is a powder. Sizes are fixed because more than say 10 mm plus 10 mm size is there, coal size is there. So that is mixed with coal for getting charged, and this is giving a better uh, coke properties. Like if I do not know whether MICOM values and other things are known to you, but these are improving this use of tar decanter sludge. Then coal chemical department, then catch pit sludge and tarry waste, it is whichever is not getting recycled back, it is disposed in the secured landfill. From coal rolling mill, we get zinc dross. Now, when we heat zinc, zinc bath is for galvanizing. Zinc bath is boiling zinc is there through which the sheets are passed for coating. Now, after uses, some spillages and other things gets solidified, which is called zinc dross. Idea is to improve upon the process to reduce the generation of this zinc dross, and whatever zinc dross is produced, it is sold to authorized parties. We cannot sell to everybody, but there are authorized parties to which this zinc dross is sold. Then it is the acid sludge, because pickling is done by acid. So acid sludge is thrown into they are disposed in secured landfill. Now besides there are some sludge containing heavy metals, because as you know the steel uses chromium, nickel and other alloying elements. So lot of certain sludge will always contains heavy metals which gets leached into the soil, and once it leaches into the soil, it can get mixed with subsoil water which is used for drinking, and it can contaminate it. So that is very much important that we make impervious layer secure landfill, and actually dispose of all these type of sludge into that secured landfill. Now I have dealt with solid waste and liquid waste. Now coming to disposal of gases, because the coke oven gas. Now, coke oven gas, which I told that once we heat the coal in the ovens, the hydrocarbons are coming as gases, and it is around 30% of by weight. Around 68% pure carbon is there, and rest is the gas comes out in the gaseous and moisture form, which contains carbon monoxide, carbon dioxide, ammonia, and other gases which comes out. Then it is also having some coal dust and other things which goes to air wash, that washing this gas is washed, and then through electrostatic precipitator whatever suspended particles are there, it is separated and the clean gas, it is going into the fractionating tower, where the tar, benzol and ammonia are separated in the fractionating tower. Tar being the heaviest, it gets separated first, and then benzol, then ammonia. And ammonia is also used for getting reacted with acid, that is sulfuric acid, producing ammonium sulfate as manure, which we sell outside. At least Raurkala has got that. Ammonia is separated and uh, 1000 kilocalories per normal meter cube. So pure coke oven gas is used for only certain places to ignite the burners, but generally it is mixed with blast furnace gas and LD gas, and mixed gas is used as a fuel for any reheating furnace in the reheating purposes in the plant. And basically the mills which has got reheating furnaces are getting this mixed gas as a fuel. Even the blast furnace stove heating or any heating process is happening through this gas, and the gas produced is 100% utilized. Any excess gas which is coming out, it is to be burnt before letting out into the atmosphere. Special chimneys and special burners are meant for that. So that all these gases are going to the burners. Any extra gas, but normally it is going into the grid for burning. And there are in certain plants there are gas holders also to make use it on the at a later stage. 4,000 kilocalories per normal meter cube. Similarly, blast furnace for process, blast furnaces, there are a lot of gas getting generated, and through the upcomers and downcomers, it is taken to the scrubbers and then electrostatic precipitator, where the heavy dust and fluid dust is taken out, and the clean gas, which has got CV of around 8 cubes, so it is mixed with coke oven gas in a fixed ratio. And if it is mixed in 1:1, then it is the CV is around 2,500 kilocalories in normal per normal meter cube. And so there are systems gas, and the gases are then cleaned and separated of the dust, and it is then collected into the gas holders and fed into the grid for getting mixed together and to be used as a mixed fuel gas. So all the three units, which that is blast furnace, coke oven, and SMS, they produces gases, and these gases are led into the grid for in the gas grid for heating purposes. So all these gases are, and but one thing is that if any gas is to be let out in the atmosphere, it has to be burnt. Because why? Because this contains very lethal gas, that is carbon monoxide. As all of you know, if it goes into the human body, then the oxyhemoglobin will convert into the carboxyhemoglobin, which is very lethal, and it will cause death. So even if somebody says that I am dizzy, or I have gone to the gaseous place and I am dizzy, gas lag gaya, then we have to take necessarily him. We have to take to ICU and keep him under observation for at least 2 to 3 days before he gets normalized. And oxygen is given to that fellow. Blast furnace gas is supposed to be the most lethal gas because it is colorless and odorless, and nobody knows that हमको gas लगने वाला है. If, and you get affected, and sometimes if it is there, cases have happened and get affected by the gas. So we try to avoid. If it is to be let out in the atmosphere, it has to be burnt. And burners are there, special before letting out the atmosphere.
Excuse me, sir.
Air pollution. हाँ बोले.
Sir, sorry to interrupt, sir. Sir,
Yes.
actually, another session that is at 3:30,
Yeah.
sir. Sir, kindly try
Oh.
to wind up, sir, before 3:20.
हाँ, I will
sir.
ask you.
Okay.
I will ask you. अच्छा,
Okay,
time हो गया. Okay.
Okay.
पता नहीं चलता है.
हाँ sir, definitely.
So the air pollution is also an area of concern for us, and these are the few chimney emission norms that you can go through. That is Coco 150, then captive power plant 100, sintering plant 150, BF stoves 50, blast furnace dedusting it is 100. Then SMS, there are two norms, that is while blowing, while oxygen is blowing, lot of dust is getting generated. So that is 300 ppm, and in the normal operation it is 100. Then steel melting shop. So you can go through this. These are the stringent norms, and SOx and NOx. These are the norms given for it, which you can which you have in the presentation. Now, only thing I want to tell that the CPCB and State Pollution Control Board is monitoring these stack emissions, and they are the norms are now getting stringent. Like this 150 will go to 50, and then up to 30. That is the plan. So we have to improve the emission control equipments, and technologies, modern technologies are to be adopted. Now coming to the water treatment plant, as we have seen that wastewater is treated, and the treated water is recycled back into the process after cleaning and treatment, and fresh water is taken only as makeup water. And now you must have heard that we are going, all the industries are going for zero liquid discharge. That is, no blow down water will be given. And as you know that all plants are having townships, so the sewerage water is also treated, and this sewerage water cannot be fed back into the as potable water, but then the sewerage water is treated and fed into the process water system of the plant, and is used as a makeup water plant, so that the requirement of the makeup water plant from the fresh pond is less. And special water treatment plants are being set up in order to suitable for use as process water to stop blow down completely. So zero liquid discharge we are trying to go. Now CDQ, that you know that coke was being formed by heating the coal in absence of water, and then cooling it by quenching through water. But now that we will see that in later on, that it creates a lot of phenolic water and hazardous chemicals, which is detrimental for health. So now that CDQ, that is coke dry quenching, is adopted in order to avoid any water quenching. So this improves the coke quality as well as reduces the hazardous waste generation. Now wastewater treatments process and equipments are like this: oxidation plant, biological oxidation, and depeneration, that is called BOD plant popularly. There are also COD plant, then neutralization units, where we use certain additions to neutralize the effluent. Then settling tanks are there. The primary settling tanks are and secondary settling tanks, so that the heavy particles and the fine particles are separated. First, in primary settling tank, heavy particles will be separated. Then in secondary settling tank, fine particles will be separated. Then clariflocculators are there, where we actually, there are centrifuges, large centrifuges, where the water goes outside and the impurities gets collected and they are dried. So earlier these two things were happening in two separate units. Now it is clariflocculators have come, which does both the things. That is cleaning water and making dry the uh, sludge or muck which is collected in the center. Then oil catch pits, I told that even the rainwater and other things, when the oil gets mixed, these oil catch pits are there uh, to remove the oil from the, because the water, the top surface, oil is floating, so that catch pits are made available. And in the primary secondary settling tank, there are skimmers which skims out the oil, and this oil is collected and through pinch rope system, as it is separated out, and uh, I must tell that once it is separated out, these are going for, these are oil is reclaimed, and certain treatment is done and then getting reused. Then filtration unit, that is rapid sand filter and pressure sand filters are there to separate out any particles. जैसे आपका रेत में छानते हैं पानी, वैसे ही मतलब the natural sand filters are there and pressure sand filters are there where we force water to the sand filters. Then sludge thickeners are there, which I told the clariflocculators are come. So sludge is thickened. So sludge thickeners are coming and which is left into a certain area and then try to get dried up. Most of the plants, like Russian plants, are having two separate water resources or water ponds. One is meant for the processed water, where all the processed water is coming into that and it is taken back into the system through that pond. So the impurities get settled there. And fresh water pond is there from which the makeup water is taken into the processed water pond. So this is a system for so that no contaminated water flows out. Now, in a BOD plant, there are three stages of biological treatment. So, first stage, the phenol is separated by pseudomonas. It is written here. You can go through. Then, second stage, the cyanide, which is very detrimental. You, as you know, all of you know it. That cyanide is there, which is processed through trickling filter and multicellular organisms. Then third stage, ammonia nitrosomas and bacteria is there. So efforts are there on to completely treat this water from cocoons and use it again inside the plant only. So from cocoon we don't want any water to flow outside, because any undulations or any problem in the system, this very dangerous or very hazardous things will flow out. So we try to now the plants are trying to reuse the total quenching water, which is phenolic and rich with cyanide and ammonia, to treat in BOD and COD plant and then reuse it in the system. And certain water is definitely going into the blow down system. So that also flows into a lagoon. And there again, 4 stage, there is a residence time of 4 days into the lagoon, especially made large water ponds, which where settling is taking place, neutralization and equalization takes place, and before coming out of this lagoon, the water is fit for letting. Yes, please. Yes, please.
सर गुड आफ्टरनून, बजट परिषद से वंदना बात कर रही हूँ.
हाँ, बोलिए.
सर एक्चुअली रजत ट्राइब में रहना होता है ना आपका?
I am in a meeting, please. Okay. So after it flows out, this neutralization and equalization, the water is fit to be fed into the natural stream of water, and this is being controlled by State Pollution Control Board all the time, and it is being monitored by our own. Means all the steel plant has got an environment management department which controls it. Then there are e-waste. As you know, you are well aware. You are a user of more into this, that IT and telecommunication equipment, then consumer electrical and electronics. All this produces lot of e-waste, because when it gets not fit for use, it goes into waste either. So these e-waste are the disposal is to be governed by e-waste management rules, that 2016, that applies to all manufacturer, producer, consumer, e-retailers, refurbishers, etc. So this is one. E-waste are also generated. Lot of e-waste are generated because today our all communication system is through electronic media. Then, as you know, that any plant will have a health center, and sale plants especially have got large hospitals where a lot of biomedical waste are getting generated. So they have to be disposed by incinerator, plasma pyrolysis, autoclaving, and microwaving. Either we have got own agency or own facilities, or there are authorized agencies by state pollution control board which have to be used for disposing this biomedical waste. Then township, most of the large steel plants are having their own township, and that generate lot of waste, which are also to be governed by Waste Management Rule 2016. That is segregated. Yeah, all of you know today the Swachh Bharat Abhiyan, that all has to be separated into biodegradable, non-biodegradable, and hazardous waste. Now they are being collected by waste collectors from door to door. And recently I read a news that in Raurkela they have introduced e-rickshaws for collecting the waste. So these township waste can be used for biomethanation, that is biogas, and microbial composting, vermicomposting,